In this lesson, we will be talking about one of the truly foundational tactics and content areas of the entire GMAT Focus Edition, whether it is in the quantitative reasoning section or the data insights section involving mathematics, and that's basic algebra. So let's just define linear algebra first off. So linear algebra means that it can be represented as a line in the coordinate plane. So there's just one outcome possible based on the structure. Now, there is no geometry on the GMAT focus, but this is conceptually what linear algebra is. And there's a single possible value for any variable in the equation at one time. So it's not parabolic, if you can imagine what a quadratic function may have looked like back in the day geometrically. Now, a variable is an unknown that can be different values pending the values of other variables or constants in an equation. But a constant means it's an unknown value that has only one possible outcome, so it doesn't change. So you can have a sample linear equation such as 4x plus 3y is equal to 84, because depending on what x is, that'll dictate what y is, and vice versa. Now, the strategic implications here, you want to attempt technical algebra for any clearly algebraic problem first. But you need to quickly abandon that approach as soon as it ceases to be both apparent and simple to you. Apparent meaning you can set up the algebra, and simple meaning you can then solve for the algebra. You also want to always seek to directly solve for the specifically sought unknown or the combination of unknowns. You have to beware of potentially, and this is intended by the exam, solving for something that it doesn't want. So don't auto solve for individual variables that aren't the target of the problem solving question in front of you. It's just a time waster. And that's definitely a big picture, holistic kind of skill that the exam is evaluating at all times. So this is going to be our GMAT focus algebraic order of operations. Do not take this to a math class later on in your life. But for the purposes of this exam, when everything has to be done in 2 to 3 minutes, this is just kind of the more intuitive way that the human brain processes algebra. So first, you want to eliminate fractions or decimals by multiplying your full equation by the least common denominator or a power of 10. Almost everyone is going to say that it's easier to manipulate integers as opposed to fractions or decimals. So get rid of the fractions or decimals first. Then you need to work to efficiently isolate for the sought value or values combination using your 4 basic functions, meaning the ones in the corner there: addition, subtraction, multiplication, or division, following the PEMDAS order, which of course is parentheses, exponents, or radicals, multiplication, division, addition, subtraction, where in multiplication and division are equivalent on that order level, and you just go left to right, as are addition and subtraction, because they are just opposite operations mathematically. And last, you're going to eliminate exponents or radicals by raising or rooting the full equation as necessary. And we've got an example here that we're going to execute these steps with. So you can see the equation 1/4 parentheses 2x squared plus 8. So 1/4 times the quantity 2x squared plus 8 is equal to 34. So first, we're going to multiply the full equation by 4 to get rid of that fraction. So we're just left with 2x squared plus 8 is equal to 30 times 4, 120, plus 4 times 4, 16. 16 plus 120 is 136. Then we're going to subtract 8 to isolate for 2x squared, and we discover that 2x squared is equal to 128. Then we're going to divide by 2, and we discover that x squared is going to be equal to 64. Then we square root that equation to find that x can be either positive 8 or negative 8, and that will work. So you've got to make sure that you follow the steps exactly, but because the squaring, whether it's 8 or negative 8, results in 64, you've got to remember that both possible outcomes can occur. So next, we're going to talk about what are known as systems of equations. So these are going to be used to solve for either an individual variable or a combination of variables when you're given multiple equations. These can be used to solve for exact individual variables if the number of provided equations is equal to the number of provided variables. So this is kind of the golden rule of linear algebra. In order to solve for a single variable, you must have a single equation. So if I had 3x plus 4 is equal to 17, I can solve for x. But if I have 3x plus 4y is equal to 17, I can solve for neither because I've got too many variables, not enough equations. But if you have an equal number of equations, unique equations, and unique variables, then you can solve for all of them. So I need 2 unique equations to solve for 2 unique variables. I need 74 unique equations to solve for 74 unique variables, so on and so forth. But you can also solve for a proportion, even if the number of provided variables is greater than the number of provided equations. So this is the in terms of stuff. I can figure out what S is related to T if I just have one variable relating S to T, because I can see what their relationship is to each other, even if I don't know exactly what the value of S or T is. Strategically here, systems of equations, you want to make sure you articulate your information consistently with the fewest number of variables possible. So what does that mean? Well, if I've got the nonfiction books plus fiction books equals total books, I don't want to consider 3 different variables. I want to have N for nonfiction, F for fiction, and just consider my total as N plus F, rather than introducing a third variable of the total. Always try to articulate your information with as few variables as possible. Few unique variables, that is. And recognize that substitution of variables is generally the long way to solve a system of equations on the GMAT Focus. It's not saying they can't do it this way, and if you're more comfortable doing substitution, it's possible to use, but you really want to train yourself to look for our elimination tactic instead, because you can seek savvy ways of stacking equations where you have the two same variables and 2 unique equations to eliminate whichever variable you're not being asked to solve for by finding a common multiple or coefficient and then adding or subtracting the full equations from each other. So let's see an example of how to solve for an individual variable with a system of equations. First, you're going to stack the equations vertically, aligning your variables. Then you're going to multiply to find a common multiple or coefficient of whichever variable you are not seeking in the problem, because that's the one you want to eliminate. Then you want to add or subtract your equations to eliminate all of the variables except the sought variable, and then solve for that sought variable. So we've got an example. What is the value of y if 5x plus y is equal to 45 and 2x minus 6 is equal to 2y? Well, first, we're going to stack them. We're going to align it vertically. So we've got 5x plus y is equal to 45. 2x minus 6 is equal to 2y. Next, we're going to multiply the top equation by 2 and the bottom equation by 5 so that we can have the same coefficient of our x's. Because we're trying to solve for y, we want to eliminate the x's. And we get 10x plus 2y is equal to 90, and 10x minus 30 is equal to 10y. Then we can just subtract the 2 equations from each other. Well, subtract the second one from the first to eliminate the x variable entirely. So when we do that, we're left with 2y. Remember that when you're subtracting a negative, you're actually adding it. So you've got 2y minus 30 becomes plus 30 is equal to 90 minus 10y. Then you can add the 10y to both sides and subtract the 30 from each side to find that 12y is equal to 60. Divide 60 by 12 and 12y by 12 to find that y would be equal to 5. And once you get more efficient with this and more comfortable with the system of equations, this is way faster than setting it up and going, well, let's make y equal to 45 minus 5x, plug that in. It just takes longer. It's really going to be more efficient to do the stack and solve. Now, you can also solve for a proportional value, even if you don't have all of your equations that are necessary to solve specifically for an individual value for the variables. So first, you're still going to articulate your information algebraically. Then you're going to isolate for the sought value in terms of the other variables. So we've got another example, this time a word problem. James has invested in 3 funds, X, Y, and Z. Simple enough. If 10% of the total he invested in X is equivalent to 30% of the amount he invested in Y, and the amount he invested in Z is half what he invested in X, what fraction of his total investment is in fund Z? Whoa, right? There's a lot going on here. So we've got to break this down very carefully, very deliberately. So we just articulate the statements in algebra. So 10% would be 0.1. Of the totally invested in X is 0.1 times X. Is equivalent means equals 30%, 0.3 of the amount he invested in Y, 0.3Y. That's our first equation. And the amount he invested in Z is half what he invested in X. Well, you can see I'm putting X on the left-hand side just to start to align everything, but 1/2 X is equal to Z. And our total, rather than calling it a total, a unique variable, is going to be X plus Y plus Z. So we're trying to figure out what fraction of the total investment is in fund Z. So we've got to relate two variables to each other as opposed to three. So we'll set the total in terms of X and Z only, and that's going to tell us that when we do our X, our 0.1 X is equal to 0.3 Y, we can we can multiply the whole thing by 10 first to see that X is equal to 3Y. So that means that Y is equal to 1/3 X. So when we're considering our total as X plus Y plus Z, it's X plus 1/3 X plus 1/2 X is equal to X plus 1/3 X for what's been substituted for Y plus Z. So now I've got them relating X to Z only, one all X's and one X's and a Z. Then we multiply by 6 to eliminate all of our fractions. So on the left-hand side, we're going to end up with 6x plus 2x, because 6 divided by 3 is 2, plus 3x, because 6 divided by 2 is 3, is equal to 6x plus 2x, because 6 divided by 3 is 2, plus 6z. So now we combine our x's so that we have 11x is equal to 8x plus 6z. Now we've got to relate z in terms of the total. So we know that 6z is equal to 6 of 1/2 x. So 6z is equal to 3x. So that tells us that 3x out of 11x is our total of z out of the total. So it's 3/11ths of the total because the x's cancel out when we put z in terms of x and put the total in terms of x as well. So you can see, again, a lot of steps happening, a lot of little technical opportunities to get stuck. But if you just work deliberately through the process, probably get everything into fractions, keep it very constant in how you're working through it, you can figure out what would probably be estimated by the exam to be a relatively difficult problem. So let's head on over to the whiteboard to see how you'll execute on your scratch pad when you encounter algebra problems of various types on the GMAT Focus Edition. As always, we set up our scratch work A, B, C, D, E. First, put a little line over top of what we're being asked for. And I'm going to write out my answer choices because there's a really big spread between choices A and B and C, D, and E. And I'm going to just use the shorthand of K for the ones with the 1,000 to make it a little bit easier on myself, but I should be able to determine whatever this question is asking, whether it's in the hundreds or in the hundreds of thousands, pretty quickly. So if we skip to the end, we're being asked for the cost per widget, and I'm just going to say W at SC. So already, if I'm running out of time on the section, I very well may go, probably not C, D, or E, but we'll make sure of that first. So, Sasquatch Corporation's total monthly expenses. Okay, so MTHLYEXP are equal to a fixed monthly cost, so we'll call that F, and a variable production cost that is directly proportional to the number of widgets the company produces that month. So F plus W times, we'll just call it V for variable cost. That's it. If SC's total monthly expenses are 405,000, okay, so we've got 405,000 is equal to 1,000 widgets. So we've got F plus 1,000 times that V, and it's 515,000 in a month when we've got our F plus 1500 V. We're now looking for the variable cost per widget. Well, right now, I know it's V that I'm solving for, and we'll just put V as the variable that we're going to use. It's kind of redundant when it's a V. It's alliterative, as it were. But we know logically now it's not C, D, or E. So if I'm running out of time, I might make an educated decision to just be like, you know what? I'm not going to worry about solving for this specifically. But when we've got it set up, we don't even have to find a coefficient here because it's nice of them that they've set it up that F is already the same coefficient in both of our equations. So I can just subtract the two equations directly from each other and have only V left. So the F's go away. I've got 515,000 minus 405,000. So that's going to be 110,000 is equal to 500 V. Because remember, you got to subtract everything down. So it's 1,500 minus 1,000, 1,500 V minus 1,000 V, not plus, even though the plus is there. And you can always put a parentheses around that to remind yourself of how you're managing your second equation combination. Now, at this point, there are basically a couple of ways that we can work through this. Obviously, I know that it's not C, D, or E, but you can see there's a big old trap if you're not careful about what you're being asked for in choice C, because you might go, ooh, 110,000. That's not what I'm asking for, what the problem's asking for. I need the variable cost. So then I can cancel out the zeros, at least two of them, immediately. And I'm looking at 5 going into 1100 at this point. And looking at my answer choices, logically, we probably can go, well, 5 is going to go into anything over 1,000, some number more than 200 times. So it has to be this one. But just finishing out the long division, because it doesn't really take that long, 5 goes into 11 twice. 2 times 5 is 10. Subtract out the 10. We've got 10. 5 goes into 10 2 times. Subtract out the 10, and we've got a 0. Bring up the 0, and there's the full accounting of why our variable cost per widget in the scenario is 220. Now, this is the kind of problem where you'll say, could I back solve? And the answer is yeah, but it's probably not fastest. Do challenge yourself to try to attempt the more direct algebra in a word problem, because if the exam believes that you can set up the algebra, it's kind of wanting you to do that. In other instances where you've seen like weird exponential algebraic functions, a different approach might be better. And remember, flexibility in approach is one of the skills that the exam rewards most. So let's go ahead and take a look at one more example here. And this time, we'll set up our scratch work as always. We've got A, B, C, D, E, put a little line over top, and we're looking for what T is equal to. And I'm not going to write out our answer choices this time. We've got an in terms of S. So we've got all of these variables throughout. We've got a bunch of S's. We got a bunch of T's in the problem. So these are going to be plugging in easy values or modeling clues. So I could potentially model this. You could plug in a value for S, determine what T is, and work through it. It's still probably going to take a little bit longer than we'd like on the exam, though. So let's say, yes, I could model this, but I'd really rather not because it's apparent algebra. And we know that if the algebra is readily apparent, we'll use a little quotation marks because that is our metric, as it were. We'll just say really attempt to technically manipulate first. So that's what we're going to do here. So we can see that they're telling us that T times S does not equal 0. And the reason for that is if both T and S are 0, then the whole thing kind of means nothing. But we'll set up our equation. We've got 3S plus 4T. is equal to 4s minus 6t all over 7. So we remember, we want to get rid of the fraction first. So if we multiply the whole thing by 7 on each side, the right-hand side, it cancels out the 7s. And on the left side, we just have to distribute the 7. We get 21s plus 28t is now equal to 4s minus 6t. Probably don't want to deal with the negative at the outset, so we'll just add 6t to both sides. We'll subtract 21s from both sides to isolate for our variables on either side of the equation. So 28 plus 6 gives us 34t, and 4 minus 21 gives us negative 17s. And so we're trying to find for t, so that means that we're going to divide both sides by the 34. So t is equal to negative 17 over 34s. If you know that negative 17 over 34, 17 is exactly half of 34, you can reduce this, but I don't even have to because I could see that there's a negative s over 2 that's the only viable option really at that point, because it has to be some negative value that is not an integer, and the only possibility that's valid is b. But of course, if you divide 17 divided by 34, or negative 17 divided by 34 in this case, by 17 over 17, you'll get to negative 1/2 s. And negative s over 2 is the same thing in notation as negative 1/2 s, because you could just put the s over the 2, because you're dividing s by 2 as a negative. Anyhow, as you saw through these examples, the direct approach is the one you should attempt first. So when you go and practice some problems on your own, make sure that you're giving the technical algebra a decent attempt before possibly moving on to alternative tactics as you improve your skills with algebra on the GMAT Focus Edition.